In 2026, Richard Delsid assembled 3 large pizzas from scratch in 31.22 seconds. That involves hand-stretching the dough, ladling the sauce, and distributing every topping in less time than it takes to tie a pair of shoes. Speed is irrelevant if the quality is sloppy. Judges stand directly over the prep table, scrutinizing the distribution of the pepperoni and verifying that the sauce maintains a precise clearance from the crust line. Hitting that sub-32-second mark requires a rare combination of muscle memory, aerobic endurance, and psychological focus. A single tear in the dough or an uneven spread of cheese adds the fractions of a second that result in instant disqualification. This level of mastery is built on a highly controlled, small-scale environment. However, perfecting the physics of a single pie on a prep table provides no preparation for the logistical dangers of scaling up mass. This is the floor of the Los Angeles Convention Center, occupied by 13,957 square feet of unbaked pizza. Constructing a structure this massive requires 13,653 pounds of dough, 2.5 tons of sweet marinara, and the manual placement of over 630,000 pepperoni slices. At this scale, the culinary challenge evaporates. You are now managing a volatile, high-stakes biological ticking clock. Massive quantities of pizza dough act as a live, breathing organism. Over a 48-hour prep cycle, the dough is constantly fermenting and expanding, reacting to every minor shift in the ambient temperature of the convention hall. These logistics must stretch horizontally when records move outdoors, such as the 1.15-mile Neapolitan record in Naples. Here, the dough is exposed to wind, humidity, and the uneven heat of the coastal road. Coordinating that distance required 250 chefs to work in perfect synchronization. One mistimed pull, or an uneven stretch, and the mile-long membrane rips. At these dimensions, a recipe functions as a highly unstable supply chain. Success depends on engineering rather than cooking. Even with the dough in place, the primary obstacle remains: transferring heat across a surface area the size of a building. This diagram illustrates starch gelatinization. For the crust to set, the dough must absorb water and lock its structure. This requires simultaneous, balanced heat hitting the dough from both above and below. Standard ovens cannot provide this balance. Engineers deploy custom rigs to crawl over raw ingredients. If heat zones fall out of sync, gelatinization fails. When conduction from bed heaters outpaces dome radiation, the result is a blackened bottom and raw top. Securing the record has nothing to do with perfecting the flavor. It is about defeating the unyielding laws of thermodynamics. The validation process functions as a high-stakes structural inspection. Adjudicators use thermal probes to verify that the core temperature of the crust has reached the required threshold. Only once those probes confirm the starch has set is the 13,957 square foot expanse officially recognized as a cooked pizza. Verification immediately triggers another logistical hurdle. Guinness rules require that the record-breaking food be fully processed for human consumption to prevent waste. Crews use metal cutters to slice the behemoth into sections, loading them into refrigerated trucks bound for local charities and food banks. The engineering feat is verified, and the behemoth is immediately repurposed for its ultimate utility: feeding the hungry. This industrial scale stands in total contrast to the 1889 standards of the original Neapolitan recipe. When Queen Margherita first tasted these 3 specific varieties in Naples, she established a standard of simplicity and moderate proportions. The authentic Neapolitan pizza is now legally protected by the European Union. Its heritage is built on specific local ingredients like San Marzano tomatoes and buffalo mozzarella, used in precise individual portions. Engineers can stretch the pizza's dimensions to the horizon, but the Neapolitan tradition remains anchored in its original, small-scale proportions.